Welcome back to REXA, electronic actuators. Today we're showing a small linear actuator with a spring fail function. This model is commonly implemented and retrofit onto steam turbine governor controls for pilot valve operation. 100% duty cycle motor. It's a servo motor driving a positive displacement gear pump. And we're just transferring oil from one side of a cylinder into the other to get motion. So I change my set point here. My motor activates. I reach position. Motor stops. The unit has very short dead time, 70 to 80 milliseconds, and very rapid response. 100% duty cycle, so it can continuously position the turbine valve and maintain that RPM. So I'll demonstrate the actuator's fail-safe function. I'm going to run the unit up to 100%, and I'm going to simulate activating a trip signal for a turbine overspeed condition, some kind of a load rejection condition. And you'll see the actuator rapidly move because the solenoid is going to open and the spring is going to send that valve to the fully extended position within 100 to 150 milliseconds. So watch that spring. As soon as I reapply my trip signal or reapply my power, it goes back into automatic mode and you're back in control. Now you might wonder, can I actually trip that at that speed, partial stroke, for a condition for a cogen installation where you're using auxiliary steam for another process and you don't want to fully close the steam valves on a trip or an overspeed. You want to just pinch those valves off to say 20% without going full closed. Can we do that in 100 milliseconds? Doesn't sound feasible because of that. To stop a mechanical device moving at that rapid pace is not easy to do. But with our technology we can do that. And we have a set point in here called a surge break point. You calibrate that for if you have a condition where your control signal changes by 40% or greater, that means that it's an upset condition or a trip condition or a load rejection condition. You want the actuator not to go from 100% to 50% with the motor. You want it to go with the spring and solenoid in 100 milliseconds and stop right on that set point and control. I'm going to run the unit down until the egg cracks. The egg cracked there. Now I'm going to rotate the unit to the egg so you can see the crack. Okay, the crack in the egg is open at about 28% of calibrated span. Now I'm going to run it up to 100% and bring it back down to 27% so you can see here. So I've instantly brought my signal from 100% to 28%. The egg did not break, it did not overshoot. One more time. Now to show you that it is a raw egg, we will run it down to from 100% to 0%. I will give it a trip signal to go to 0. Or I'm going to kill power, so it's not going to stop at the set point, it's going to go to the end of the travel. As soon as I reapply power, it goes back to set point, which is 100%. That's 0. Calibrated 0%. And that's our steam turbine pilot control governor actuator with a high-speed trip and high-speed partial load rejection function built into it. Thank you very much for your attention. You can learn more about us at www.rexa.com.